Hello. Today we're going to look at the layers of the atmosphere, and make sure you have your notebook out because you are going to take notes as we go through this. So again, we're talking about the layers of the atmosphere, um, and so the atmosphere is the layer of gases that surrounds the planet and makes conditions on Earth suitable for living things. And the Earth's atmosphere is divided into several different atmospheric layers extending from Earth's surface outwards, right? So going from the surface of the earth, right? The big blue green ball thing floating in space, going outward towards space. It's broken up into layers. So what we're going to look at is the layers of the atmosphere, how they actually go, right? So if you look at this arrow right here, starting with Earth and going out to space, okay, you start with the troposphere. That's the one closest to Earth. And then the stratosphere is the second, mesosphere is the third, thermosphere and exosphere, right? Those would actually be together in the same one, but we're going to break them up for our purposes. Okay, so thermosphere and then exosphere, right? Or you can look up here and look as this arrow goes out towards space, you have all your different layers of the atmosphere in order: troposphere, stratosphere, mesosphere, thermosphere, exosphere. So go ahead and draw this in your notebook, right? This little chart right here. And what I want you to just put is troposphere, closest layer to the Earth. Stratosphere, second layer to the Earth, right? Contains the ozone layer. Mesosphere, third layer to the Earth. Thermosphere, fourth layer. Exosphere, last layer, right? So go ahead and write that in there. Troposphere closest, stratosphere second, mesosphere third, thermosphere fourth, exosphere last. So just kind of looking at these, right? That troposphere is where all the weather occurs, right? That's a big one. Okay, every type of weather that happens on Earth is happening in the troposphere, right? The closest layer to the Earth. It is the closest layer to the Earth's surface, and it is the layer that we live in. All right, very important to remember those. The stratosphere is located directly above the troposphere, and this is where the ozone layer is. All right, the ozone layer is a really thin layer of the atmosphere, and it's located on the very top part of the stratosphere. The next layer is the mesosphere, followed by the thermosphere, and then the exosphere. So again, going from the Earth's surface outwards, all right, that's the order that they go in. So atmospheric gases, nitrogen and oxygen make up something like 90%. I want to say it's something like 90%. So again, if you draw this in your notebook, all right, nitrogen and oxygen make up about 90% of the Earth's atmosphere. All right. Ozone layer is about, I think it's like 0.5%. I'm actually looking them up right now. So it says oxygen and nitrogen make up about 99%. And then everything else, right? All these other ones are going to make up about 1%. So this is 99%. Then these other three are going to combine together to make what would be about 1% of the remaining amount of nitrogen and oxygen. Okay. So I want to say ozone is like 0.5%, maybe a third. And then water vapor and carbon dioxide is about 0.5%. And then trace gases is very, very, very minute, right? This is all the other gases that we have in our atmosphere, right? So nitrogen, oxygen, 99%. This right here would be about 1/3%. This is 0.5%. And then this is all the remaining. Okay. And it's very, very, very small, but it just tells you how large the atmosphere is that we can get all of that helium and argon and all that stuff out of our atmosphere. And right, there's really not that much compared to nitrogen and oxygen. Nitrogen and oxygen, these are the two most common gases found in the atmosphere, and they can be found throughout all the layers. It's actually very interesting. They did a study about 20 years ago where they were trying to figure out why our atmosphere is the majority nitrogen, right? If you ever look it up, nitrogen's about 70% of our atmosphere, maybe, give or take about 1 or 2%, but roughly about 70%. And it's just interesting to see that, when they did this experiment, that they dropped the amount of nitrogen and they raised the amount of oxygen, and a certain level of something like 36% oxygen, just random fires started breaking out everywhere because there's so much collision of elements in the atmosphere, that energy of those collisions was just igniting fires because there was so much oxygen, right? Because oxygen is a flammable gas. And then they dropped the nitrogen level down, or they increased the nitrogen level, and they decreased the amount of oxygen, and they found that it was very difficult for organisms to breathe, right? So it's really interesting how fine-tuned our atmosphere is for living organisms with the amount of nitrogen and oxygen. The ozone is a form of oxygen and is only found in the stratosphere. O3, and we'll talk about this more when you come to class, but O3 is oxygen single bonded with another single bond of oxygen. And it's really odd because it only happens in the atmosphere. It's really interesting how ozone works. Water vapor and carbon dioxide, these are very important gases for weather conditions, obviously, and they're found in that troposphere where weather occurs. Okay, there's not much carbon dioxide or water vapor found outside of the troposphere. Trace gases, these gases are unimportant and found in small amounts throughout the layers of the atmosphere, right? An example would be argon. So the atmospheric temperatures, these are the differences in temperature, are what separate each layer in the atmosphere from the one above and or below it. So go ahead and draw this chart in your notes. Okay, so draw this next chart in your notes. And what we're going to do is we're going to end up drawing some arrows in this chart. And it's going to be very important that you know this. Okay, so in the first column, you're going to put altitude, and in the next one, you're going to write temperature, right? So altitude in the first column, right? So going back here, draw this box. Okay, draw this in your notebook. And in this column right here, it's going to be altitude. This column is going to be temperature. Okay? So looking at the troposphere, as altitude increases, temperature decreases, right? Think about walking up a mountain. As we get higher on a mountain, the temperature is going to go down. Okay? Altitude goes up. I'm walking up the mountain. Temperature goes down as I get higher in the atmosphere. Okay, the next one's the stratosphere, and this works opposite of what we know, right? The stratosphere is cold except in its upper region where the ozone layer is located, right? So as we go up in altitude in the stratosphere, temperature is going to go up. So altitude goes up, temperature goes up in the stratosphere. In the mesosphere, this is the coldest layer in the atmosphere. As altitude goes up, temperature goes down. Right, so altitude goes up, temperature goes down. In the thermosphere, okay, even though the air is thin in the thermosphere, it is very hot. Okay, it's just really interesting. Probably why it's called the thermosphere, but it tends to block a lot of solar radiation, and so that reflection of solar radiation is going to make that layer, that atmosphere, very, very, very warm, right? So again, altitude goes up, temperature goes up. Okay, again, we're getting closer to the edge of space, right? More and more radiation is being blocked and pushed back into space, so the temperature is going to go up the higher in altitude I get into the thermosphere. And then the exosphere, okay, beyond the thermosphere is the exosphere, which leads into outer space where it is very cold because there is little to no atmosphere to absorb the radiation, right? So altitude goes up again, temperature goes down. All right, altitude goes up, temperature goes down. Now, looking at pressure, okay, so I'm going to have you draw that box again, right? We're going to go ahead and draw another box. Okay, go ahead and draw this again. All right, because now we're going to look at atmospheric pressures. So in the stratosphere, air pressure is the force exerted by gases pushing on an object. Air pressure is greatest near the surface of the Earth in the troposphere. We're going to look at a video on this when you come to school tomorrow. So in the stratosphere, altitude goes up, pressure goes down. And this ends up happening everywhere. Okay, sorry, I keep flipping back and forth through slides, but this ends up happening in every layer, right? So as altitude goes up, pressure is going to go down in every single layer of the atmosphere. Okay, air pressure is greatest near the surface of the Earth, right? So the farther away I get from the surface of the Earth, the less pressure there's going to be on me. There's less pressure exerted on me. And again, we're going to look at a video when you come to school tomorrow. So it's pretty cool. All right, solar energy. Okay, solar energy is just energy from the sun and is known as solar energy. Solar energy is the driving energy source for heating Earth and circulating in Earth's atmosphere. Solar energy, some of the sun's energy coming through Earth's atmosphere is reflected by gases and or clouds in the atmosphere. So again, we talked about the thermosphere. It reflects that solar radiation back out into space. Clouds do the same thing. So the top parts of clouds are actually reflecting that solar energy as well. All right. The solar energy coming from the sun heats up the land, which releases heat fairly quickly, right? Ground releases heat quickly, right? Water takes a really long time. We're going to look at another video tomorrow on how water works, but water needs to absorb a lot of solar energy to warm up, right? Water has a very high heat capacity, right? It takes a lot of energy to raise the temperature of water. Okay, it is the water on Earth that helps to regulate the temperature range of Earth's atmosphere. This is why cities that live near the ocean or cities that live near large bodies of water, like Montague with Lake Michigan, okay, the temperature, not so much with the Great Lakes. Okay, I should rephrase that. Not so much with the Great Lakes. It is somewhat similar, but not so much. But definitely cities that live near the ocean. Okay, Juneau, Alaska tends to stay like 50 degrees year round, right? It ranges from like, I think 45 to like 70 year round. Okay, it doesn't really fluctuate all that much. It's because the ocean is right there. Okay, having a large body of water next to you as a city, it really impacts the amount of heat that your city experiences. Solar energy that is absorbed by the Earth's land and water surfaces is changed to heat that moves or radiates back into the atmosphere, the troposphere, where the heat cannot be transmitted through the atmosphere, so it is trapped, a process known as the greenhouse effect, right? And this is where that convection starts happening in the atmosphere, right? Think about what we talked about with convection, right? That's circulating of masses of gases and liquids. Okay, this is where that's happening in our atmosphere. Nope. All right, I believe that is the end. So thank you for listening to my monotone voice. I tried to be excited about it, and we'll see you guys tomorrow.